Hi guys, you're welcome to today's class. Today we have another topic on physics called inclined plane. It's a lot of students have been we have actually been solving problems that has to do with the inclination of angles. For today's topic and this time topic, so to say, it will really be on inclined plane. We'll see how to resolve forces on inclined plane. Now we have here the figure below shows a block of mass 50 kg which is kept at rest on a smooth plane inclined at an angle 30 degrees with the horizontal by means of a string attached to the vertical wall, just as shown here. The question is A. What are the forces acting on the block? B. If the string is cut off, what will be the acceleration of the block down the plane? This is actually a GCE question. Excuse me. Like I said, I usually solve problems. Some are really past questions, and some are questions that I get from textbooks, as in, to really work on expected assignment of students. And sometimes I actually pick up those ones that I assume will be difficult to students because of the intricacies involved, so that you see how it is done. Now let's dive in into this and see what we have. I have here solution. Sorry about the board size, but we'll still make do with it. Solution. We have, like I always say, let's see what we have here. We are asked to A, what are the forces acting on the block? And B, if the string is cut off, what will be the acceleration of the block down the plane? Now let's resolve the forces here. This is an inclined plane. If you have, sorry, have something inclined like this, and this is a wall where the string is attached to. This is the body, string attached to this. Try to make it okay. Now it's also sliding downwards where there is a weight which is equals to mg sine theta, and there's a vertical force here, that's weight on the y-axis rather. Now this the body, the weight coming downwards. This both are still weight, but I still put it like so that they can resolve even weight mg cos theta. Now the body is sliding downwards, causing a tension T on the string. This is S axis. And remember, we're trying to resolve the forces acting here, acting in this diagram here. Now, I haven't seen this. I haven't done this. Is theta. Okay, I haven't done this. Let's resolve the first force. So resolve the forces acting on the body. The first one here. Okay, let's say A. The first force AI is weight. The weight will be coming down. I also have what we call a normal force here, and the force acting upwards while weight is acting downwards to keep the body balanced even though while sliding. While we are weight, which is W, is equals to the mass times relation due to gravity of the object sliding. Now weight here will be equals to, remember, we have a mass here to be 50 kilogram. So and acceleration due to gravity G, like I say, if it's stated good, if it's not stated, you assume 9.8 meter the second square. Now I have here weight to be mass acceleration due to gravity. The weight here, the mass given is 50 kg multiplied by 9.8. Therefore, the weight, which is one of the forces on the body, is 490 Newton. I've gotten the weight. Another one here is what we call the normal force. The normal force is noted at N. Now this normal force here says summation F of y is equals to 0 because the body is not going upwards, rather sliding downwards. Normal force here will be mg cos theta equals to 0. That's the angle it forms. Now the mass here is 50 times 9.8 cos 30 degrees. Cos 30 degrees. Therefore, the normal force here will be, if you multiply 50 by 9.8 by cos 30 degrees, you will have 424.4 Newton is the normal force. Now we also have tension. I. We also have tension. These are the forces acting on the body, on the block that is sliding. I have tension T here, also a force acting. We'll have that T minus weight equals to 0. Therefore, tension minus, which is the weight, mg, and the angle it forms, sine theta, equals to 0. Therefore, T equals to mg sine theta. Then the tension here will be, the mass is 50 times 9.8 sine 30 degrees, being the angle it forms. Now, if you multiply this together, you have tension to be, have tension to be 245 Newton. Now, the A part of this question is solved as this. Now, let's check the B part. Say, if the string is cut off, what will be the acceleration of the block down the plane? If the string is cut off, either here or either any place, and the block is sliding down, remember this string is holding the block to the wall and causing pressure, causing tension. Now if the string is finally cut off, what will be the acceleration of the block down the plane? Let's see how that goes. Sorry, divide the board. Now B, we have here summation f of x equals to ma, mass acceleration. Now we have here the mass acceleration due to gravity by sine theta minus tension equals to ma. Now mass here is 50 times 9.8 sine, the angle is 30 degrees minus. Now when since the mass, since there is a, since the string has been cut off, there is no tension again, so tension will be 0, but there's no tension again, equals to the mass 50, and since there's no more tension, acceleration, we also, we have to ask for, you have to look for the acceleration, so we have to get it. Now we have here, therefore we have a 50 times 9.8, 50 times 9.8 sine 30 equals to 50 multiplied by acceleration. Therefore, acceleration here will be 50 times 9.8 sine 30 over 50, because we're looking for acceleration. Now this 50 will cancel this 50 to have acceleration to be equals to, if we multiply 9.8 by sine 30, we will have 4.9 meter per second square as the acceleration. As simple as that. The question states what are the forces acting on the block, which the forces here are weight, normal force acting upwards, opposite weight, and the tension, which is holding the tension on the string, which is holding from the wall to the block that is sliding. And this is the acceleration with which the block slides down the plane. As simple as this. Thanks for watching, and watch out for more problem solution on inclined plane. Bye.